Hi, let's talk a little bit more about dominant designs. I'm going to use a toy, a kid's cash register, to illustrate the point. The dominant design is the core technology around which a practice revolves. In retail trade, when you go to checkout, here's your core technology. This is what they ring up the sale on, they keep a record of it, and they put the cash in and out. When I was a kid, there used to be a lever here to open it. Now, there's been an innovation. Boom, you use a chip and it opens. Because you have a chip in it, whoops, forgot to turn it on, there we go. Now it'll open, just like that. Because there's a chip in it, I can put a calculator on it. So I can say 5 times 3 equals 15, and I can do all sorts of mathematics on it. If I want to store the transaction, I don't need a second tape in here that I then put in the safe. I can put a wire in the back of it, take it out and ship it someplace and store that transaction for inventory control. I can order off of what's being sold. Notice that once I go electronic, I can do some other things. Here's a slit. There we are. Let me zoom in here so you can see the slit a little better. There's the slit on it. I bet you can guess what that's for. That's right, it's for the credit card. We no longer take money just in cash. We do transactions using credit cards as well. So I can do just about any kind of transaction with this cash register. Now let's look at what this means. Before we talked about different types of innovations, let's review that. We can have innovations that are related to the function that's being performed. That is, we're just doing that function better using the same metrics, and innovations that are related to how we do it. Are we doing it with the same technology or with different technologies? So we have a matrix with 4 cells. Same function, different function, same metrics, different metrics, same technology, different technology. An incremental innovation would be, once I have this chip in there, how do I open the cash register even faster? I'm opening it electronically, but maybe I can do a software upgrade so that it opens easier. That would be an incremental innovation. Same basic technology, same metrics I'm measuring performance on, it's just faster doing it with a better software than the prior software. I can look at an adaptive technology, which is different metrics, same technology. Once I put the chip in to open the cash register, I might as well have the calculator. That's an add-on. And once I have the calculator, I may want to put a wire in and transmit that data back to the computer. All that's based upon leveraging the chip that's in here. So it's the same technology, different functionalities, although there is an argument that putting a wire in it is a radical innovation because I'm adding something new. If I do the same metrics in a different way, I take cash, I put the cash in the cash register, I want accuracy. I put my credit card across it, I'm taking the cash, I want accuracy. It's just a different way of taking cash. That's a radical innovation. Different technology, same metrics. Change both the metrics and the technology, then you have a disruptive technology. What would be disruptive in the case of the cash register? Let's get rid of it. Let's just use a chip in the credit card. That's called a smart card. It has a little Bluetooth device in it. It walks by a little box. The little box pops up the information as each RFID chip goes by on the product. It calculates what's going on, and the chip goes by. There's no contact at all. The human's not even involved in it. You see early stages of these kind of things when you go to stores like Home Depot and you're doing the barcode checkout, and the traditional cash register is really gone. It's all a point-of-sale system. That would be a disruptive innovation. Okay, what's the point of emphasizing these? Well, once I understand what the dominant design is, I can position my technology vis-a-vis that dominant design. That tells me something about how easy it's going to be for my end users to use it. Tells me something about the levels of reliability people are going to expect by looking at the value I offer versus the overall value of the dominant design. I get an idea of how to price it. Whole slew of things become clear if there's a stable dominant design in an area. In the next session, we'll come in and talk about what makes for a stable dominant design. See you then. The core to stable dominant designs are regulations and standards. What do I mean by that? Well, here's a small fluorescent light bulb. These things, fluorescents have been used for years in businesses, in buildings, industrial, commercial kind of stuff, but they weren't ubiquitous in the home, even though they're incredibly energy saving compared to the traditional incandescent light bulb. Why? It wasn't until they figured out how to make the ballast smaller and then put it together with the standard socket so you could put it into any light fixture that the fluorescent light bulb became ubiquitous. In other words, there's a standard out there for plugging things in. We see plug-in standards all kinds of places. Here's another plug. Let me zoom in one more time. This is the plug for a microphone. If I don't have this, it doesn't work anymore. That's why I need the adapters to plug it into my iPod or my MP3 player. Here's another kind of plug. We have different plugs in different countries, but this is a power plug. This is an old pencil sharpener, electric pencil sharpener. Here's the plug that goes into the wall. There's a standard for that. There's the RS-232 port. Standards solidify, ossify dominant designs so that you can design and know what's going on. Notice that when you try to break away from a dominant design, there's a penalty. A number of years ago, we did a project for a small firm out in Arizona. They had designed and invented a new type of plug. In the plug, there was a little bar and there was a piece of metal, almost like a solder, that held the two prongs together. If the plug overheated, the solder melted, the prongs split apart. It was a safety device, so a socket, or rather a plug doesn't overheat, burn down the house. Very attractive from that standpoint. Cost almost nothing to make. So you would think that it would come in no-brainer. The problem was when they designed it, they forgot they needed UL certification. And they didn't design the plug to be easily certified by UL. Because they were a small money, they couldn't afford the fee that UL charges if you want to develop a new testing protocol. Thus, they had to bear the full cost. That was the showstopper for them. They were not able to get to market. So, dominant designs are more stable where standards or regulations enforce them. That happens over time because there are certainly utilities for everybody to have the same way to plug things together or to understand what's going, train for the dominant design, develop certification programs for people so they can work with technology based on the dominant design, like people get a radiography certification to work with X-ray machines and so on. There is an incentive to keep the dominant design as long as it's generating utility. It's only much later in its life cycle when new technology comes in that is so far superior that it will traditionally typically bust the dominant design. That new technology tends not to come in as a direct competitor to the dominant design. It comes in some kind of little niche field, like our zipper came in as a competitor to the buttons, but it came in saddlebags for the military and galoshes, not as a ubiquitous thing for clothing. Okay, now that we've introduced dominant designs and we've talked about how they get solidified and stabilized, let's move on to our next discussion.